All right, everybody, and welcome back. I'm here today with Zoe and Patrick, head TAs for the class this semester. And we wanted to start this as video updates for the class to talk a little bit about some of the competitions that we have coming up, give you some recommendations for what to expect in these competitions, and give you some advice also in building. So today we're going to talk a bit about the next competition, which is going to involve placing the shrink race on the side of the centerpiece. We'll talk a bit about those tasks, as well as some rule clarifications that are going to be important in the sequence for this competition. With this first mechatronics competition, we're doing the same tasks that you had to do in the previous competition, which involved clearing out these wooden cylinders, the missiles. But we are also having to do this task of avoiding the wooden block, which is the children here on this bullseye. We're doing both of those tasks, and we're adding the task of placing the shrink race here on the side of the centerpiece. And you're doing all this based on input from the track that's provided when we hit the button to start the track. And then you will have to have your system respond to that input and do these different tasks. So just like in the previous competition, this is all going to be based on your ability to clear out these missiles with avoiding the wooden block, and then getting and identifying your strata and quadrant and placing the shrink ray in the appropriate zone. So those based on the cumulative amount of points that we give before trials. And we're going to have Patrick talk a little bit about the sequencing for what you can expect in this competition, since it's a little bit different than the individual competition.
Great. So this week coming up, you're going to have your mechatronics components be used for the first time. So your MyRio needs to be programmed and ready to interface with the track, so I recommend you practice setting up your robot in the 3 minutes and 45-second time period. Now, what are you going to do in that 3 minutes and 45 seconds? Well, I'll show you. So whenever you get to the track, you'll have your robot in your hand, like so. You're going to carry it over. I'm going to carry it over to the black starting zone. Just to show you, you're going to carry it over and set it down as soon as your professor says take the track. Now, I've set my robot down. I've got 3 cables coming out the back. The banana plugs, which need to go into the connector on the track. And this is how the track tells your robot to start. Then your 2 power sources, your MyRio, and your driver board power sources. Now my robot's plugged in, but it's not automatically charged yet. So I have to take the pump, make sure there's air in the tank so that my actuator will activate. Then I'll take the box, and wire sticking out the bottom is okay. Should be just fine. Yeah. Now the robot's been boxed and it's ready to go. So the start button presses. Robot deploys, does its thing. And after 40 seconds, the track stops. And the points are counted.
So one thing to consider here, you can unplug that, Patrick. The first time you run your system on this first round that Patrick showed here, the robot has to stop moving at 40 seconds. So the centerpiece is going to stop moving naturally because we programmed it to stop moving at 40 seconds. If your device is still actuating or doing anything, then that will be counted as a disqualification. So we will make sure to look for that on that first round that you run of the 4 trials that you'll run. After that round is over, you're going to have to go 3 more times, boxing every time, and because if you're able to show that your system stops within 40 seconds in that first trial, you can end those a little bit earlier if you wish. But as Patrick was saying, is then from there you're going to be counting the points associated with the different tests in the competition. So that's the general sequence that you can expect from the competition. We do have these boxes. We want you to make sure that you check and see how you can use them to check height and volume. We also have these gauges here. There's a couple. There's one in the main IDEA laboratory as well as one here in the classroom. This is meant to check the height of your system because sometimes it's hard to see when you're actually having a box there. But this is a vertical height gauge for us to make sure that you're within the bounds of the restrictions for the competition. So that's a bit about this competition here that is going to take place next week. We'll pass it over to Zoe just to talk about some rule clarifications for you to consider as you build your systems.
All right, so I'm going to talk about some rules specifically about the shrink ray and the anti-shrink ray right now. So every team will be given an anti-shrink ray, which is red, and a shrink ray, which is green. And on the tips, it will have the color associated with your start zone and home base. So your shrink ray, so if I'm the white team, my shrink ray has to be put fully within the quadrant of the white team. So the quadrant for the white team is defined by the edge of this section where the light is. So this is how you can identify which quadrant belongs to the white team because of the white light. And because there's no black light, the black light corresponds to the red light for the black team. So to place your shrink ray, you can place it either in the stratosphere, the mesosphere, the thermosphere, or the exosphere. So if I place my shrink ray into the exosphere to get the maximum amount of points, I have to make sure that my shrink ray is fully within the zone. So each centerpiece has 16 zones, and each zone is defined by where it is in the atmosphere, and then also if it's in the bounds of your zone. So the shrink ray cannot be placed on the edge of any of these yellow lines. That will be counted as 0 points, and you will not get the points. It has to be fully within the zone. If your shrink ray is on one of the yellow lines that represents a different level of the atmosphere, then where the lowest level of your magnetic base is defines the location of your magnet. So technically, if I was on the line between the exosphere and the thermosphere, my shrink ray would be counted as the thermosphere. Also, if the black team puts their anti-shrink ray in the same zone as the white team, then they will not have the points. Also, the anti-shrink ray has to be put fully within the quadrant. It cannot be put on the line that will be counted as nothing. And the anti-shrink ray will also be counted in whatever level of the atmosphere corresponds with the lowest level of the magnet. You can place your shrink rays in the cutout in the mesosphere. That counts, and that's fine to place your shrink rays there. Some other things I wanted to go over is you are free to, you can displace your shrink rays or another team's anti-shrink rays as long as you are not coming into contact with the centerpiece, unless it is rolling contact in the stratosphere or momentary contact with the beacons. Again, the same rule applies for the domes. You can misplace the moons and you can move another team's moons. That's okay, as long as you are not touching the dome. You cannot come in contact with the dome. Another question was, a lot of people wanted to know if they could block another team by coming in, placing their moon, and then staying over the center of the dome. That is not okay. If you're coming in and placing your moon, you have to have only momentary contact within the zone number 2 for the moon. You can come in, place your moon, and then your machine has to retract out of the zone number 2 for the moon. It can be within your home zone quadrant, but it cannot be intersecting the zone number 2. Another thing I wanted to clarify is the rules for egress. So this square right here, this is my starting zone, and this triangle is my home zone. So if I were to egress from my starting zone to my home zone, my entire robot would have to clear this line that delineates the starting zone from the home zone. So that would count as egress. And then if my robot came over the top of the dome, so pretend this centerpiece was infinitely tall, if it crossed, it intersected that plane and came back, that would also count as an egress. And then I also want to talk about, some people had talked about projectiles. So we are allowing projectiles as long as you do not project any sort of either a moon or a shrink ray further than 1 foot from the centerpiece. And that, so when you're throwing your shrink ray, it has to either be pointed horizontally or down. It cannot be pointed up. And it has to be, the first it can be is 1 foot from the centerpiece.
The last thing we want to go over are some tips for actually constructing your robots, whether it be from managing different elements of the design to using equipment. And I think Patrick's going to talk a little bit about that.
Yeah, absolutely. So some tips and tricks for building robots. I would first recommend that you iterate as much as you can on your designs. We can see with this robot over here that they utilize laser cutting pretty often because you can quickly iterate with a machine that is over in the Invention Studio. I think there's about 4 of them. Feel free to take advantage of this privilege because it may help you design iteratively but also rapidly prototype the subsystems that you're trying to build.
The laser cutters are available in the Invention Studio. You have 4 of them there. Feel free to use those pieces of equipment. The Invention Studio is open 11 to 5 this semester, Monday through Friday. And the PIs are there to help. I do encourage you to try and use it earlier in the day because they do see a lot of utilization as you get further into the semester. I think the last thing Patrick was going to talk about was wire management. Do you want to say a few things about that?
Sure. So wire management with the 2110 robots can be hard to understand at first. But just stand by a couple of quick rules. Keep it neat. Keep it simple. And try to keep it together. So whenever you're taking wires out to a large subsystem that's far away, I would recommend that you use this wire conduit that protects the wires and keeps them together. And so instead of 5 or 6 strands of wire, you just have one large bundle to deal with. And then whenever it comes out on the electrical panel, you can see this team elected to have their electric panel mounted on the side, and that's really easy to work with. I would recommend, if you're building some sort of electrical panel, that you have it easy to either remove and work on, or you have enough space around so that you can work on it on the robot.
So we have a couple of these examples. The robot that you see Patrick with there, and this robot here as well, has a nice wire guide built in it that help to isolate those wires so that they don't get snagged as you're expanding your system to move forward into the arena. So these are available in the Idea Lab, the TA station, so you can look at these as good examples of some nice design principles in managing those cablings, and wire harness is a big problem in the industry, and hopefully you can take these as cues for your designs. So with that, we wanted to close up this video and wish you all good luck with your building activities for this competition. If you have any questions, feel free to come talk to us in the open laboratory sessions. You approach the TAs, the head TAs, or myself, or any of the instructors, and we'll help give you some advice along that. So with that, best of luck.